Hello everyone. This is a video lecture for college algebra, Math 1414, section 11.2. We are going to be doing arithmetic sequences and series. Now hold on. Whoa. Did I stutter? Arithmetic? Isn't that arithmetic? Yes, it's arithmetic, but apparently because it's an adjective, now you say it's arithmetic. Okay. Moving on, what does it mean to do arithmetic sequences? Is that you are going to add and subtract. Yep, that's all you're going to do. And whenever you're adding and subtracting, they're going to use the term D, and D means your common difference, which actually is contradictory, isn't it? So here's some examples. 1, 2, 3, 4, 5. What are we doing each time? We're adding 1. And so D equals 1. 4, 1, negative 2, negative 5. What are we doing? We're subtracting 3 each time. D equals a negative 3. That is all it is. 11, 2, 5. Here we go. I got A1 is equal to 350. D is equal to negative 90. And they say, figure out all of the stuff. So A1, well, you put 350 in. Isn't that interesting? A2, what are we doing? Well, I'm going to be taking this. I'm going to be adding negative 90 to it. You add negative 90 to it. Or rather, you're subtracting that. And so I get 260. 350 minus 90 is 260. A3, same style. I'm going to be subtracting 90. What do we get? 170. You could use this new formula if you like. I don't think it's required for that problem, but here's a formula that you could use. AN is equal to A1 plus D times N minus 1. This is my formula. I think they'll say it once in a while. They might move the D to the other side. It kind of depends on who's talking about this formula. I put my D in the front. So you could use that formula if you like. I just think it's easier to minus 90 from each one of them. 11, 2, 9. Here we go. I got AN is equal to A sub N minus 1 plus 3. And they say that A1 is equal to negative 7. This is recursive again. We saw this in the last section. We had current is equal to your previous plus 3. And so I'm going to start with A1. Guess what? A1 is negative 7. Exactly. A2. So I'm going to now say whatever we had previously, I'm going to add 3 to it. So I got a negative 4. And I'm going to take whatever I had previously, and I'm going to add 3 to it, negative 1. So on and so forth. A1 is equal to 6. I got a D equal to 1. And they say find the 50th term. Okay, now hold on. We could start to just say 6 and add 1 is 7, add 1 is 8, add 1 is 9, and we'd be sitting here for quite a long time to get 50 terms. 50 terms. I ain't going to do that. So instead, there's a formula, which we just saw. And so that's the AN, A1, plus D times N minus 1. Fill it all in. So I got my A1 is a 6. I got my D as a 1. And my N is a 50 minus 1. 6 plus 1 times 49. 6 plus 49 is 55. And that's how you get the answer. So the last term is a 55. Okay. 11, 2, 19. I got A1 is equal to negative 60. I got a D equal to 5. It says find the 200th term. Same style, same formula. A1 plus D times N minus 1. I got a negative 60 plus 5 times 200 minus 1. Sorry, that didn't look very good to me. So I do the math, negative 60, and then plus, that's 5 times 199. If you do the math, it actually comes out to be a 935. Like, from the calculator. And another one. We've got 11 to 23. Okay. 5, 12, 19, 26, dot, 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 dot. And so they want to find a formula, and then they want to find the 20th term using that formula. By formula, they mean a1 plus d times n minus 1. And I'm going to fill in what I got. This is my first term right here. How much am I adding each time? 7? Do you know what n is? No. So leave n alone. Leave n alone. Don't touch n. That's part of the formula experience. So I need to simplify. Distribute your 7. 7n minus 7. Combine the like terms. 7n minus the 2, and that is your formula for part A. Part B then says, hey, go ahead and find a sub 20. So I know now that my n is equal to 20, and I can use that formula now. 7 times 20 minus 2 actually ends up being 138, again, from the calculator. Okay. And kind of like a hard break, because they're going to now talk about new stuff now. I have a new formula for you. And this is for summations, the sum. So Sn is equal to n over 2 times a1 plus an. This is the sum of however many terms. So say, instead of saying 1, 2, 3, 4, 5 like that, I'm saying 1 plus 2 plus 3 plus 4 plus 5, and I can add these up, and I would get an answer. That's what this is doing here. S stands for sum. So as long as we're given the first term and the last term, and then however many terms are in the middle, boom, we're done. And so here's a quick example, and this is a historic example. Ooh, math history. Say we want to add up 1 plus 2 plus 3 plus 4 all the way to 100. Do you know back in the Matrix chapter, we were doing the RREF a lot? Well, it's technically called Gauss-Jordan elimination or something like that. I'm sure my math lab will use that. Well, Gauss, when he was like a little kid, he was in, I don't know what grade level, but he was acting up or something, and the teacher said, go to the corner and add up 1 through 100, and, however long it takes you. It's like, just, it's like being grounded, I guess, or something. And, well, he came back just a minute later, and the teacher's like, what are you doing, Gauss? And he's just like, well, I'm done. And so he handed her the number, and it was 5,050. And the teacher was like, what? How'd you do it so fast? Well, he probably used a formula. So he made his own formulas. That's why he's so smart. So how many terms do we actually have here? 1 through 100, we have 100 terms. I'm just using this formula. 100 terms, divide by 2, and then my first number was a 1, and my last number was 100. So I'm saying right here, these get plugged in, and I said how many do we have total is 100. So that's going to be a 50 times 101, and there's your answer. Pretty cool, huh? All right, now I didn't just show you the formula because I have math history. We actually have some problems we got to do, but I had to show that. Even if we're like trying just to get this done, it's still a cool problem. And I think your homework actually has one of those. Maybe. So here's another sequence, and they want to turn it into a series by saying add up the first 50 terms. Add up the first 50 terms. Okay? Now, we only got 4 of the terms. First off, what is the 50th term? And then you need to take all these and add them up. So, like, that's going to be a lot of work, right? Well, there's a formula for that. But first, we do need to find what the last term is. And so that's going to be an an equals a1 plus d times n minus 1. That's our previous formula we learned just a second ago. The first term is a negative 10. My d, what am I adding each time? I'm adding 5, right? 5. And then n minus 1. What's my n here? How many times are we going? Was the 50? 50 minus 1. And so negative 10. and then plus 5 times 49. When you do the math over here, I got 235. Now, that's not your final answer. That's only right here. That's your last term. So now we can actually find it. So S50, I guess, is 50 terms, divide by 2. And then my first term was a negative 10. My last term was a 235. Calculator, so I got 25 times whatever, and we get the answer to be 5625. I zoomed in again. Okay, well, there you go. All right, cool. Next one. I got 11, 2, 45. They give me summation I equals 1 to 15 of 6i minus 5. You know where to go for this, right? Yeah. I'm serious. Desmos. But Desmos graphing calculator. Now, I'm going to go and do this by hand here in a second. I mean, I'd be a bad teacher if I didn't, right? But the idea, though, is that we're trying to use our resources. And use an N, not an I, of course. There's your answer. Yep, that's confirmed. There it is. You're done. Next question. This is not a bad thing at all. So I want to still do it and show you what to do with the formula, of course. But we need, first off, our first term, and then our last term. And after that, it's super easy. The first term is when you plug in the 1. 6 times the 1 minus the 5. You actually get a 1 out of that. The last term is when you plug in the 15. 6 times the 15 minus 5. I got an 85. And so then they say, okay, we'll find out now what the final answer is. So then I got my S15 is 15 divided by 2, and then 1 plus 85 is equal to what? 645. That's your final answer. Awesome. Let's do another one. 11, 2, 49. So I have summation of I equals 1 to 20 of 3i. You know how to do it. I'm just going to go ahead and do it the long way because here's the thing. I'm looking at my notes and I'm seeing that I have other boxes. Like I have a part A, part B, part C kind of thing. And if that's the case, we will have to find this first term and the last term in the homework. Could you still do that in Desmos? I mean, yeah, of course. I mean, there's always a way. But it's not too hard to do this. 3 times 1, it's 3. And then we got 3 times the 20 is 60. See, it's not hard to do this. And since we're already here, my sum for the first 20 terms is going to be a 20 over 2. And then 3 plus 60, you end up with a 630. And we're done. Next problem, 11, 2, 63. I have 2 different companies. So I got company A is paying, I'm going to say pays, $26,000 a year, and it has raises. It has a raise of $1,400 each year. Company B pays, what do they pay? They pay $28,500, but they only have raises of $850 a year. So, which pays more in the year 10? So, which pays more in the year 10? It's a good question. Now, I have to make sure that you understand that in the next problem, they're going to ask something kind of similar, but it's not going to be in the year 10. It'll be a cumulative amount of money that you made over the 10 years. That is not the case here. They're saying literally in year 10, how much money are you making in both of the companies? Compare and tell me which one is better. So, how does this work? Well, we're not adding anything up. In fact, all we're going to be doing here is the 26,000. And I said not adding, I mean not summing, not like summation. 26,000 plus, and then this 1,400 each year for n minus 1 years. This is that same formula that we had been using just a few minutes ago. So what is n? N is 10. But notice, I'm not going to say this number here times 10. I'm actually going to be multiplying it by 9. you go into the math, and it actually ends up being 38600. That would be your salary for the year 10. Okay. The company B is similar. We got 28,500, but they're only paying $850. Again, 9 times. You're only having 9 raises. The first year you didn't have a raise. The first year is that when you started. In the year 2, in your second year, you finally got that raise, and that's why there's always 9 raises, not 10. I did the math on this one, and it's 36,150. You can see that it is not as good. So this is not it. This is better. You would say company A is better. And they say by how much. Sorry, this is just a little addendum on my notes here. By how much? And guess what you're going to do? You're going to subtract them. 38,600 minus the 36,150, and we get $2,450 difference. Okay, cool. I have 2 more problems, and like I was warning you, this is another company banking kind of problem or whatever. It says that you have $35,000 salary to start, but then you have raises of $3,500 each year. That's pretty nice. It says, what is the total salary over the next 10 years? Basically, how much money, if you got all your money back into your pocket and you put every single dollar into a bank account and did not pay any bills, you didn't buy any food, you didn't use any gas, you didn't nothing, you put it all away, how much money would be in that account at the end of 10 years? Okay? And this is a surprising number for a lot of folks, by the way. How do we get this to work? Well, they're saying this Sn is equal to n over 2, a1 plus an. Remember that this is the first, and this is the last. I don't have the, I have the first, actually. This is my first. I don't have the last. So to find my last, I have to use that other formula, a1 plus d times n minus 1. I have those numbers. So 35,000 plus the, oh, I just noticed that they're both 35s. 3,500, and then times 10 minus 1. Your salary in year 10 is 66500. But that's not your answer. Your answer is going to be the sum of all that stuff. And so that's going to be now 10 over 2. Your first was the 35,000, and your last is the 66,500. You add that up and multiply by 5, and you get 507,500. Yes, you were half a millionaire if you put every single dollar away and did not spend any money on bills or anything nice. Or anything at all. So it's kind of interesting to see that kind of stuff happen. Like, wow, I had like $1 million go through my hands. I mean, kind of. This is the stadium seating problem. It's a very particular problem. It's talking about stadium seating, so let's talk about it. They got 20 seats in the first row, and then they have 24 seats in the next row, and then they have 28 seats in the next row after that. And they keep going for 42 rows. What's your total seats? Total seats. Like, here's the thing. You go to a stadium and they want to say, how many seats do we have total here? Yeah, you're going to be counting quite a long time. And so instead, why don't you use a formula? You could see that it kind of grows as it gets higher. They get more in a particular column or something. And so you take that starting amount. You know they're growing by 4 each time. You counted 42 rows. So what's your total? Well, we need to find the first row and the last row. And then we can do the formula yet again. The first one's easy. It's 20. We saw that already. The last one takes a whole minute because that's going to be the A1 plus D times N minus 1 yet again. 20 plus 4 times 42 minus 1. You do the math, and it comes out to be a 184. So 184 seats are in the top row. And so finally, Sn is equal to n over 2, a1 plus an. That's your first and your last. We had 42 rows, divide by 2. And then I had my 20 plus the 184. Doing the math, we got 4,284 seats total. Whew. Done. All right. Thank you very much. Have a great day.